Good evening, everyone. I am Mohd Siddiqui, summer intern at Maritime Research Center and also a BTech graduate from IIT Kanpur. I have been working on the habitat suitability model for marine spatial planning with the guidance of Sridhar sir. The Indian Ocean region is the heart of the maritime trade, handling approx 40% of the global trade. Major economies supported by our oceans are fishing, which account for about 1.5% of the global GDP, tourism about 5%, and maritime trade contributes 2% of the global GDP and 80% of trade by volume, and employs millions of people worldwide. We have been exploiting our ocean without any policies or any data-driven mechanism, so which leads to major consequences like about 1 lakh of fishes dies because of fish strikes and uninformed fishing patterns waste fuels and effort with losses summing up to 50 billion according to World Bank 2017 report. So what we have, the solution is that we have been proposed is a habitat suitability model which works upon the AI. We collect the relevant data from the satellite and model it uh, using the AI technologies that we have. So with proper policy and implementation, this can act as a shield for the maritime species. So it works on the basic principle of every ML model, like collecting the relevant data, modeling it, and using the result for the better use of the humanity. Let's go through an example. Like for the one of the most ecological important species is the green turtle. So for the green turtle, according to my research, I have come up with the 4 important features that affect the suitability of the green turtles. Like the sea surface temperature, they prefer usually the 27 to 30 degree centigrade for their foraging or the nesting ground. Bathymetry, like the depth from the ocean bed, it's about less than 50 meters. Net primary productivity, which is a drive factor including all the food resources for the herbivore species. And next is the chlorophyll, which is a substitute for the concentration of seagrass and algae. So after gathering all this data from the NOAA website, the Google Earth engine, or the OBIS, which is used for getting the sighting data, the latitude and longitude from which we get the sighting data of the green turtle. So after all this, I have constructed a maximum entropy model, which because it's very convenient to for the presence only data, since we have only presence data. So based on the presence data and the environmental factor, it chooses the best best curve for that conditions. So after modeling it, we have the results, like the one in shown in the left is the suitability model for the green turtles, where the dark blue region and the blue region corresponds to the minimum probability, like less than zero point 0.4, and the region in red or blue is the high probability. From this we can infer that the green turtles usually prefer in the near shore regions, like in the coast of India and Thailand. Comparing this with a sound map given on the top right, we can inform that where the region is like in the sound map yellowish, like less sound, turtle usually prefer that location. Next, I have also similarly modeled a dolphin habitat suitability model, where one of the important features was the fishing effort. Like dolphins usually avoid where there are high vessel deployment or high rate of fishing. Bathymetry, like they usually prefer bathymetry of less than 50 meters. Shore distance, like the distance from the coast. Since dolphins are friendly to humans, so they prefer coast distance like less than 50 kilometers. And the seabed index, like something like a slope, like higher the seabed index, more the concentration of fishes, so more their presence. Similarly, I have modeled the dolphins using the habitat, using the maximum entropy model. So the result that I am getting is a heat map where the region in the blue shows a less probability and the brighter region like yellow and yellow, green or red shows the higher probability. Comparing it with the fishing effort map given on the bottom right, we can see that where the fishing effort is low, there the dolphins probability is high. So there has been a lot of recently the world has felt the importance of these maps. According to the Guardian, Sri Lanka uses them to shift fishing site from Wales to about 50 kilometers away. In 2021, Cambridge releases a press for SHM to be used as a conservation tool. And similarly, a research report has been published for using HSM as a climate assessment work. The habitat suitability heat map that have been generated can also be used as a conservation tool which support smart maritime protected areas, enable global policy compliance, and empowers government decision making, not only as a climate tool but it can also bridge between the economy and the ecology, which direct fishing efforts to productive zones. Like from this we can analyze the suitability of the mammals of the marine species. Similarly, we can afford our fishing towards that location. It minimizes fish strikes and industrial overlaps, supports tourism by identifying hotspot of species. What's the novelty, like what's the uh, uniqueness that I am bring is like it focuses on the Indian Ocean region, policy driven output, and it shows the real time heat map using satellite data. So in future, this real time satellite data inference can be used to predict migratory patterns by analyzing the heat map for every years, and also for a climate change assessment impact. So thank you. That was.